Alright, I'm gonna go over how to use tokenizers and LibTorch in Unreal Engine 5. So I'm just gonna create a C++ project, going with third-person template. Alright, now that I got that opened up, I'm gonna create the plugin directory. So to do that, go to Explorer. No, not content. Just create a directory called plugins. There we go. Alright. We got that done. Gotta open up the project. I use Rider, so I hope you guys can follow along. Should be fairly similar to Visual. Oh, great. So I got Rider loaded now. So I just gotta clone the plugins from GitHub. So I'm gonna open up the terminal here. CD to the plugin directory. And so I'm gonna have these everything linked in the description, so you can just go there. But yeah, so we're gonna start with LibTorch. Just gotta clone it. Also, the steps, like I'm gonna be basically going through everything here. So if you guys want the text version, here it is. But yeah, so clone the directory. Terminal git clone. Running at tokenizers as well. Okay. Wait, that's the wrong one. I just lost the link. So here's tokenizers. We're gonna close that, clone that too. Open Rider back up, git clone. All right. So now let's start with Atum. For me, I have to click show all files so that I can actually see the plugin directories. Not actually sure how you do that in Visual Studio, but yeah. Anyways, so the first step with LibTorch is to download the release version of LibTorch. Okay, so you go to this link, and it works with CPU or CUDA. I use the CUDA version, but it's bigger, so you can go with CPU. But anyways, I've already downloaded that, so I'm just gonna skip it out here. But yeah, it's this version. All right, so go to the directory where you downloaded that. You're gonna extract this. Yeah, so I'm gonna open this up with WinRAR. No. We need to include in the lib directory. And we need to put these, let me open it up. In Win64, LibTorch U5, and source third party LibTorch 164. So the stuff is already here, but at least the include directories are, but like just for version issues and like for if you guys want to do this with a later version, I'm just showing you all the steps anyway. But yeah, so open this up in Explorer. I'm just doing this to get the path. I might as well delete this because it's gonna yell at me that it needs to replace stuff. Yeah, okay. So go back to WinRAR. True. Extract to a specified folder. There we go. Okay. This is gonna take a minute. Alright, so after that's extracted, we gotta make some changes. So go back to your IDE and like under LibTorch Win64, include torch C source API include, and then in here, okay, we'll start with torch enum. Find the enum.h. It's right here. Okay, open that up. Then you gotta replace this line of code. Okay, doesn't want to show up. That line of code right here. So this is in the instructions as well. Oh, you don't gotta replace it. You just gotta remove something. I lied. Yeah. So remove this. Okay, that's first step done. Now we gotta go to neural network. This is in the same directory. And look for module.h. Okay, and here find the module class. That's this basically. And then yeah, there should be something. Yeah, friend classes. All right. So just Control F, find note. Thanks, Copilot. Very helpful. But yeah, and add this line of code. There. Okay. So those are the changes done. So after this, we can compile, and this is gonna take a long time. Just a fair warning. But when this is done, we'll go on to the next step. Okay, so now that that's compiled, I'm going to show you how to actually use it. You might notice that this is a different project. That's because I didn't want to wait around for it to compile. Also, I have like no space, but that's besides the point. Anyways, so it's going to be set up in the third person character, but it's not actually where we start. So you got to create the layer information and then the actual neural network. So why don't we start with the layer info. So right click and go down to miscellaneous data asset. Okay, and then look for Atum neural network layers data asset, just like that. In this, I'm just gonna name this like YouTube layers, sure. All right, open that up. That to the side. Okay, so this is where you're actually gonna like define like your settings and like what the layers actually are and stuff like that. So for this, we're just gonna keep it really simple. Oh, also something that's important. So the network that I'm gonna be showing you, it's basically set up like a sequential model. What's that thing called? Okay, one sec, I gotta find. Okay, so it was actually the sequential that I was referring to. So yeah, you know how like in a sequential you just like define the layers that you want to put in, and then the input for one, like it will feed it to the con2d first, and then that into the relu, into the con2d, into the relu. It's the same sort of concept here. So I just have this set up with 3 linears. So input goes into the first linear here, then the second, then the third. Okay. So I'm just gonna set up a basic network. Gonna do linear to Gelu, sure. No, really. There it is. And to linear. Okay, so then you put like the options they're defined in this data asset here. So we're gonna go in features 4 to 24, and then also you gotta give this a name. I named these like random things. I guess actually I should probably give it a good name. No, linear, and I guess it doesn't really matter, but like whatever. Okay, name this. Just name it value, whatever. In place. That doesn't really matter. Anyways, and then go from 24 to 10. The toy network linear out. Okay, so now that we got that defined, got to create the actual neural network. So go down, like right click again, and then find, no, not artificial intelligence, machine learning. Oh, gotta close that. That's not. Okay, right click and go down to machine learning, Atum neural network. Select that. Okay, YouTube. I'm naming it YouTube NN. Okay, open that up. Now you gotta select the data asset that you just created. All right. Now once you do that, name the layer. So this is like the actual the main neural network that you're going to be interacting with. Okay, so give this a name, my model. Oh yeah, you can't. I'm so dumb. I forget that you can do like spaces with Unreal Engine. Anyways, so initialize the asset data. We got that done. All right, and now we're gonna actually test this out. All right, so third person, and I do have something set up here, but I'm just gonna go through it again. Actually, I guess we can. No. So we start with, I'm gonna make the model variable. So let's go model, and that's gonna have a type of Atum neural network. I can't spell. Okay, Atum neural network and object reference. Okay, then we're good here. You don't have to initialize that. Well, technically you do, but like you did that in the neural network here. Anyways, okay, so we'll just go through with like a simple example first. So let's make a tensor. Okay, no, this is for the optimizer. I was just looking if I like already had it set up, but no, I don't. Create tensor. No, that's not it. Make empty tensor. Yeah, and then you gotta set the value. I guess I can do like a random tensor because it doesn't really matter. Anyways, select class, so we're gonna want that to be a float tensor, and then you gotta do your shapes and the device. The person who like originally made the repo, he has all of these set up. I don't really know if all these will work, but you can try. Anyways, so we got to create the sizes. How do I usually do this? All right, so we're creating the random tensor. So we're just gonna make drag off that, make array. So this is what shape you want the tensor to be. I guess we'll just go with the. Now let's go 2D. Okay, so that's batch dimension, and there we go. Wait, what did I say? Sorry. Okay, we need 4 for the input features. So no, 2x4. Ah, nice. Anyways, so we create this tensor, set it to a variable. Oh, I was looking for begin play. Anyways, you can set it to a variable if you want, but I don't really know if I'm gonna do that. I'm gonna bother. So then you get the model and call the forward. Okay, and then you're gonna give it the input. And then this is just a basic example, but anyways, you can print these, but like, I guess they're context sensitive, whatever. So you have to convert it. Anyways, I'm just rambling. Okay, so we'll go to begin play. Or, I mean, we'll go test this out, and of course, nothing happens. Okay, yeah, so I forgot to do something. Forgot to actually select the neural network. So go over to your model variable and just select, yeah, the model that we created. Mine's named YouTube NN. Okay, so now this should work. Yeah, and there we go. Okay, so that's the basic neural network. Okay, so the other thing that you can do is like put neural networks in like as a layer here. Okay. So to demonstrate this, I'm gonna just create a new layer asset. So go down to miscellaneous, data asset again, layers, okay, and then just go other and then I'm just gonna do one linear here. So the output of this model here, one that we're working with, oops, but it is, what's, okay, I can't find it. There we go. It's 10. So we got to make that the input here. Input 10, and then we'll go 24. Sure. Name this other. My names are so bad. Okay, so you can make so you can select like a neural network here, and then basically just go down to options and select other neural networks. So that's the one that we just created, other NN. So save that and then initialize it. It's already showing in there because I already did this and didn't record it. It's going back, but anyways, that was my phone. Don't know if you heard that. Okay, so let's test this. It should all be set up still. So just go play, and yeah, that worked. How we can tell that worked is like columns. I should make the time longer, but anyways, 1 to 10, and then the second part was 21 to 24, I believe. Anyways, okay, so that's the neural networks done, and now we're gonna move on to tokenizers. Okay, so for tokenizers, we're gonna finish getting the files. I kind of forgot that, like, I don't know why I separated it this way, but I cloned both originally. So all we need is the library here. So if you go over to releases, you just need this tokenizers underscore c.lib. So you're gonna download this and save this to let me find the directory and it needs to be saved to tokenizers. So here, tokenizers and source, third party, x64 release, tokenizers c.lib. Okay, so mine's already in there because, like I said, this is a project that I already set up. But what you would do is basically just open this up in Explorer, get the path, and then just download this one file and save it there. There, I mean, right here in this directory. I think I'll put the path in the description as well. But anyways, so once you have that put in, you just have to compile, and then you're all set up. Okay, so the second thing that we're gonna need is to actually get a tokenizer. I know you guys like I haven't shown you how to use Llama, but we're just gonna cover the tokenizer right now. So go over to HuggingFace, because that's what the tokenizer library works with. It actually it does support sentence one piece as well. I think I still have to set that up, but like all it takes is just like implementing a couple functions and stuff. So if you really need that, probably look at code. I don't know. Anyways, so download the tokenizer.json file and save this to you're gonna want to put it in the content directory of the plugin. So tokenizers library. Wait, no. Tokenizers. Nope, still no. Okay, here, the content directory. So open that up in Explorer and then download the file here, tokenizer.json. Yeah, save that to this path. So it's the content directory of the tokenizers plugin, just to be clear. Anyways, so once you have that put in there, you can actually use the tokenizer. And graph. see if I have this set up. Nope. The functions disappeared, I guess, so I have to set it all up again, but that's okay. Okay. So first start with create a new variable. I already have one named Tokenizer as I did not prepare well for this, but let's name this one YouTube Tokenizer. Sure, that's different. Okay. So get that tokenizer and then create asset node, construct object from class. There we go. No, that's not even right. Okay. Never mind. So we'll just get the class there. Construct Atum network. Okay, wait. When you create the tokenizer, you actually have to set it to the tokenizer. By you, I mean me, because I forgot. But anyways, change the variable type. Sure. Then it's gonna yell at me, because of course it will. Get class construct. Let's just go create construct object from class. The reason I did that is just because it said like Atum on there, because I messed up with the type. Anyways, so we get that constructed, and then I'm gonna set it. Also, you hold down the Alt key and drag off. That's like if I just drag it off regularly, I have to click get and set. But if you hold Alt, and it's set. And control for get. Most people probably already know that, but like maybe someone doesn't. Anyways, so we're gonna set that, and then gotta encode. Or no, we actually have to initialize the tokenizer. So yeah, drag off that, initialize tokenizer from JSON. So you can do it from like a file as well. I'm not really sure, like I'm fairly new to Unreal Engine, so I'm not really sure like how people tend to store like data and stuff. So like if you have some other way to store like that you want to store the JSON, what you do is just load like the JSON from wherever and then go initialize from JSON. I know the name isn't very descriptive because JSON could also be a file. And of course I even picked the wrong one, but anyways, so we're gonna be doing initialize from file. Alright, so the file path, it's gonna be relative to the plugin content directory. So that's why I said to put the tokenizer there. Yeah, so whatever the path is, like I said, relative to that directory. So ours is just gonna be called tokenizer.json. Alright, we got that. Fine, and then encode the text. Yeah. Drag off. Never mind. Alright, so you drag off this, go encode. And here are your tokens. So let's go. This is a test. So this is like what you would actually feed into the neural network and stuff. I'll probably set up a better way to interop between like the encoding. I guess it's not bad because it's like an array of integers, but like just get the types right, stuff like that. But nonetheless, so it's encoded. And then we're just gonna decode this. This is just the example. Decode. Decode. Alright, and then we'll print this. Just to show that it works. Okay. And of course something messed up. Because it always does. Okay, so basically, don't do what I did and drag off this to get the class. Because that was giving me an error. The like can't access none type. You actually have to manually type in like tokenizer wrapper here. Okay, and then with that should work. Yep, this is a test. Just gonna make that print for longer. Change the color as well. I guess you already saw it, but here, now you get to see it in red. There you go. Okay, the last thing I'm gonna go over is how to run a basic training loop. Okay, so I already have the code set up here. So this is the traditional training loop. Anyways, so you get the parameters, construct the optimizer like you would in Python and stuff. Actually, I probably will make like the code in Python. Make the code. I'll attach the Python code equivalent to what I'm doing here. But anyway, so you construct the optimizer, and then I have my inputs set up here. File. But yeah, so I write 2, 2, 3, 4. It's just random. You can do this as like a random value and stuff too, like we had set up before. But this is just the other way to create tensors and stuff. Like if you actually want to use your own values. Anyway, so from the inputs, I'm just getting the shape here essentially. There aren't like 2D tensors and sorry, there aren't 2D vectors in blueprints and stuff like that. So if your inputs are set up like if you need a 2D vector, I think you're gonna have to handle that yourself. Okay, so we got the inputs set up here, and we're just getting the length to get the shape. Then we're using that to make an empty tensor. And then we're setting the values to the values here that we created. So this is like the manual way of doing it. Yeah. Anyways, so we've set the values of that tensor. And oh my god, my names are just horrible. What is new variable? Oh, this is supposed to be the model. One sec. This was set up with like hacked together demo where like I didn't name anything at all, but yeah. Okay, so you drag off the model, do the forward with the tensor that we created, and then here I'm doing mean squared error and stuff. Basically, so I'm just using the output and label, like both are the same, so like the loss will obviously be 0, so you wouldn't want to do this, but this is just a demo. So yeah, you get your loss, and then you call backward on that loss, and then optimizer step, set gradient to 0. That's the basic training loop done. So what you can do is just like set timer by function name and stuff. Yeah, test model. Sure, test. I guess train would be, but I guess I'm not really training it to do anything because, like I said, the loss function is stupid. Okay. Okay, so I went ahead and created everything that we went through in the tutorial in Python. So we're just gonna go through that. So we're gonna start with other neural network is what I named it. And that was just the linear layer, like wrapping that in a model to show you that you can put like neural networks inside other neural networks. So for that, it's very simple. It's, yeah, it's literally you're just wrapping a linear one, like the forward, all you're doing is calling the linear and putting that back out. I know how I mentioned that it was just sequential, but since there's only one layer in this other neural network, there wasn't really a point of putting that in a sequential because it would perform basically the same thing. But anyways, okay, so the other thing that we have is this model here. I did do the sequential container for this one because I needed to feed the inputs one to the other to perform the exact same way as what we created in the tutorial. anyways, so here we have the linear to ReLU to linear, and then it's calling that other neural network that we created, this one here, which is just the linear wrapper. So I created the exact same thing. There are more variables, like because we're doing everything in the init here, whereas in here you get to specify all the variables for each layer, like as you define the layer data. But yeah, so the input will come in here, go to the linear first, then ReLU, then linear, and then to this other neural network here. So this is basically the exact same as what we've created here. Yeah. So the forward call, it's just calling the container, which we went over previously, feeds input one to the next. Okay, anyway, so we're done that section. So now we get to move on to the test model loop. I kept the function name the same, even though it was very bad. Well, I guess it's fine. So yeah, we start with creating the optimizer. Also, I realized that you should not be putting this in the loop. Don't create the optimizer for each training step. You want to do that at the beginning, and then basically just after this step, you'd want to take this out here, all this optimizer stuff. You'd want to take it out of this function and only call it once, and then just use the real optim variable after that for when you do the optimizer step here. Set gradients to 0. Anyways, I'm gonna take a second and just comment everything here so it'll be more clear. Alright, so I got everything commented out here. So the comments are the exact same. So when you look at something here, like if you want to just go through this yourself, you should just be able to look at the comments and then see what's happening in PyTorch. I'm not going to be adding too much to this section, but yeah. So we're creating the optimizer, and remember you're going to want to move this outside of the function if you're doing a proper training loop. But yep, trying to keep things consistent, which is why I didn't move it. But anyways, so we're creating the empty tensor. So for this, just getting the length of the inputs that I set here. So inputs, they're the same value. Okay, can't pull that up right now, but they're set to the same values here. Just a list of floats. Yep. Create the empty tensor using the length is exact same here. And then fill the tensor with inputs. So for Python, you actually have to loop through your inputs and then set like each index of the tensor, but it's abstracted away in a function here, and I don't even think you have to do that for LibTorch, but that's beside the point. Okay, and then after that, you're calling the forward pass here, and then the mean squared error loss, where you're using the output as both the target and the input. I don't know if it's called the input or output. I don't remember what the variable name is called. I'll probably put something on the screen. Okay, so then you call the backwards pass here on the loss that you get from the mean squared error. And then optimizer step and 0 gradients optimizer, and then you're done. Great. Okay, so I created a Discord server as well. So if you guys just found that video really confusing, like have no idea what I was talking about, or just want some clarification, you can come here, ask questions. There's currently no one in here, so I should be able to give you guys a fair amount of attention and stuff. Any concerns that you have, or if you want to build off of this, I'm here to help. Just send me a message, or send a message in here, I mean. Yeah.